Hi, I will be speaking about simulation of circular supply chains in the white goods industry. My name is Saman Amer. I'm the co-founder of CirBES and leading the work on circular supply chains in the EU project that CirBES is part of. CirBES was founded in 2014 on the vision to create value for business, environment, and society simultaneously. We specialize in the implementation of circular economy principles, ranging from value proposition models, product design, and supply chains. Our portfolio consists of awareness and knowledge building workshops on circular economy, quick checks on circularity assessments, as well as in-depth assessments using simulations. Our offer also consists of an experiential hands-on workshop with CirBES game. This webinar is being recorded as part of ReCIPSS project. ReCIPSS stands for Resource Efficient Product Service Systems, where we have two demonstrators from white goods and automotive industry. The white goods demonstrator in this project will implement a pay-per-wash model for 300 customers in 4 European markets. The automotive demonstrator is based on the after-sales solutions, and in this project, the focus is to close the loop by using a single service provider and streamlining the logistics flow, of course. In this project, CirBES is contributing with the work on circular value and supply chains, supporting the demonstrators with circular supply chain simulations that helps in decision making. For the simulation of white goods demonstrator, the main question was, how can new service business models with refurbishment be operated in 4 European markets? Garania is one of the leading European manufacturers of domestic appliances with production in Slovenia, Serbia, and Czech Republic. Garania's product portfolio ranges from cooking appliances, dishwashers, advanced washing machines, dryers, and refrigerators. Garania has the ambition to become the global manufacturer of washing machines and provider of laundry pay-per-wash offerings to ensure long-term sustainable competitiveness both in the B2C and B2B segments. B2C segments caters consumers who move often and are concerned about upfront costs, such as students, environmental conscious people, or people who would do their laundry as much as possible carefree. Whereas in B2B segments, the consumers can be laundrettes, student dormitories, other businesses, etc. The product considered for the simulation is an ASCO washing machine consisting of more than 40 components such as side panels, door, shock absorbers, the drum, electronics, etc., and has a loading capacity of 8 kilograms and weighs 75 kilograms. The 4 markets for the ReCIPSS project have been chosen based on sales volume and existing supporting infrastructure. The washing machine relevant for the simulation is a domestic professional built-to-last model that is produced in Vilnius. Each washing machine will be refurbished twice and serve over 3 life cycles of 5 years. Typically, the washing machines reach their end of life on average after 12 years of use. To identify the best supply chain setting to launch 300 washing machines in 4 European markets, the first step was to understand preconditions for transformation from the conventional sales model towards a service business model considering 4 European markets in Denmark, Netherlands, Austria, and Slovenia. Reverse logistics seems to be a challenge for Garanier. Critical factors for reverse logistics are the location of dismantling facilities, the warranty processes of second-hand spare parts, the issue of geographical dispersion of the customers, which also increases the logistics costs. The first step in the modeling was to create a baseline of existing supply chain of Garanier. Therefore, we explored the existing logistics setup of Garanier, the organization of sales channels, how the service network organization is being operated in the chosen 4 markets. The operational aspects are explored in light of service innovation and maintenance. It is an expansion of Garanier's current after-sales and logistics network and deals with the questions on the location of repair centers, the required operational functions such as inspection, repair, availability of spare parts, etc. 4 SBUs, sales and business units, at 4 locations in Europe are considered. At the end of the first life cycle, washing machines are collected and brought back for refurbishment. Products which are at the end of the second and third life cycle will be sent to Slovenia for advanced processing. Advanced processing refers to any processing beyond refurbishing to complete remanufacturing. The market boundary for the simulation is assumed from the deployment of washing machines through SBUs until the customers within the chosen 4 markets. Based on Garanier current after-sales setup, both own and independent service networks are considered in different markets. Customers can terminate their contract before the product reaches the end of life cycle and order a new type of product, premium, economy, or budget. The probability of contract termination in the simulation is assumed to be 10%. Premium and budget products will be supplied to SBUs by Slovenia's main production facility, and economy products, depending on the scenario, can be provided either by SBUs, by Slovenia's main production facility, or central collection and service hub. 2 main scenarios are considered for the white goods supply chain: decentralized and centralized refurbishment. Decentralized scenario means that the SBUs are responsible for refurbishment in the respective markets, whereas in centralized scenario, the machines will be refurbished in a central service hub. The role of the SBUs can extend from contract management, machine deployment, providing maintenance and service, carrying out refurbishment, and storage of machines. The central service hubs can have the functionality of larger capacity for refurbishment processes, as well as spare parts stocking and machine storage capacity. The supply chain attributes of the service-based business model being considered are the environmental impacts, cost of service, and transport. The maintenance and repair service procedure is considered similar for all scenarios. The organization of maintenance and repair activity operates through the sales and business units. The frequency of these services at the customer side with the service technicians are modeled in the scenarios. Service and maintenance requests will be triggered by active tracking of machine usage. Moreover, 2 types of service will be considered at different intervals of time: repair and scheduled service. The intention with providing the service and maintenance is to keep the machine in running condition at the customer and avoid the transport of washing machines from the customer to the sales and business units. As you can see on the slide, the challenge was to find feasible alternatives to the current logistics setup to decrease both cost and CO2 emissions. The model simulates the installation, deinstallation, and refurbishment of washing machines from the SBUs to the customers in the respective markets. When a customer signs a contract for a washing machine, SBUs deploy the washing machine through the service technicians at the customer site. At the end of the life cycle, the washing machines are collected from the customers and brought back to the SBUs for repair or refurbishment. At SBUs, the machines can be bundled, inspected, cleaned, and refurbished, depending on the simulated scenario. The stages of collection and refurbishment are modeled as a process in the simulation. The repair and service requests are generated by the customers from the SBUs on intervals defined in the model. For arranging the experimental settings, design parameters for the economic and environmental performance are created with an input value based on company data and discussions with the company's representatives. The cost parameters comprise of transportation cost, service, refurbishing cost, and warehousing cost. Similarly, The environmental performance is based on the CO2 emitted during transport, service, and refurbishing. To build the model, first actors were created in the GIS space. The parameters such as costs and CO2 were defined in the simulation. The next step was to define the amount of products to be shipped from one entity to another and the frequency of vehicles movement, meaning that the vehicle movement logic has been created using a series of state charts. Next step was to define the movement of washing machines among different agents and the frequency of service trips. The washing machine movement logic has been created using the state chart. Upon arrival at the customers, depending on the type of request, the technician either unloads the machine, services or collects the machine, and then moves back to the SPU to await the next request. At SPUs, the vehicle loads the washing machines from the storage and moves to the customers if they have ordered a product. The service, repair, and collection of washing machines is triggered by the customers in the model. There are different types of requests made by customers: repair service, contract termination, or ordering a new type of product. The customers initiate the repair service request approximately every 1.5 to 4 years. The scenario of repair and maintenance with decentralized refurbishment and SPUs. In this scenario, repair and maintenance is carried out through SPUs at the customer site. However, it mainly focuses on the decentralized collection and refurbishing of washing machines in the respective markets. In this scenario, the washing machines are taken back to SPUs when a customer terminates their contract or when the machine reaches the end of life cycle. SPUs may act as hybrid facilities with refurbishment capabilities. Therefore, the refurbishment is assumed to be done in each market's SPU, and refurbished products are then distributed to the respective markets. In this scenario, we explored the centralized refurbishment of products. It depicts the return of washing machines by the service technicians to the SPUs. At SPUs, the machines will be collected and bundled to be sent to a refurbishing facility. Refurbishment in this case means inspection of the appliance after usage by the previous customer and putting returned appliance in a reusable condition by the functional and aesthetical repair and cleaning proposed by the white goods demonstrator R&D department instruction protocols. Therefore, this scenario simulates the collection of machines from the customers to the sales and business units. Moreover, it also simulates the travel distance, processes for refurbishment, and associated costs during the collection and service intervals. The scenario focuses on the centralized collection of machines through a central service hub serving all the 4 markets. The service hub with a potential location in Germany can either act as a collection center to move the machines for refurbishing and remanufacturing at the production site or with extended functionality of refurbishment. The potential location of Germany is explored because of being geographically in the middle of the other 4 markets. In the simulation, the aspect of centralized collection is explored through two sub-scenarios: centralized collection in the central service hub and refurbishment in the main production plant. In this scenario, SPUs send the collected and bundled products to the central service hub in Germany. There, the washing machines from all 4 markets are collected and bundled again and then sent back to the main production in Slovenia. Therefore, refurbishment or any other required advanced process will be done in Slovenia. These refurbished products are sent back to the respective markets from Slovenia. Another scenario that is considered is the central service hub is able to act both as a collection and a refurbishment center. Consequently, refurbished products will be supplied by this center to other four markets. These scenarios deal with the potential location of collection centers, the available capacities, capabilities of the facilities, and spare parts stocks to be able to refurbish the machines. The scenarios explored the aspect of centralized collection of machines as well. These scenarios were created by assigning the aspect of centralized and decentralized refurbishment of washing machines to a combination of locations that led to the identification of the most feasible strategy of setting up refurbishment facilities that are economically feasible and environmentally viable. It is worth noting that these scenarios were created to act as a decision support. However, the implementation may look different in the real setting. As you can see also from the scenario analysis, refurbishing process cost is lowest in Slovenia compared to other three markets and Germany. Transportation cost is also lower for centralized refurbishment in Slovenia in comparison to centralized refurbishment in Germany because Gorenje has its own service network in Slovenia. The decentralized refurbishment scenario is more cost efficient than centralized refurbishment scenario in Germany due to less washing machines movement from each sales and business units to Germany and associated transport costs. Thank you for listening. You're very welcome to contact me for questions and comments about this webinar or our offers at CirBES.